Okay, so moving forward to the next idea in this organic chemistry series, and that idea is the homologous series. Now, the word homo here means same, and the logos that represents something that we can call as a pattern or a sequence or a series or anything. Okay, and what is this homologous series is something that we're gonna discuss in detail in this particular lecture. And before we go into that, I'll just write down some of the name of the homologous series families that you're going to be studying in this entire organic chemistry series. But you might not know them right now, but I'll explain it in a way that you'll get the idea of what the homologous series is. Okay, so let me write this down. So you have something that we call as alkenes, then alkenes. You also have alcohols, and you have carboxylic acids, carboxylic acids, and you also have esters. Okay. Now you see all of these. There are a total of 5 of them, and the idea is these are individual homologous series. So for example, if I take an example for alkene now, alkene in itself is a complete homologous series. Alkene is another homologous series. Alcohols is another homologous series. Carboxylic acid is a different one. Esters is a different one. The idea is within these homologous series. So let's say, let me explain it this way. So for example, I take an alkane molecule. Okay, we haven't started alkene. I'm just giving you the general idea. Alkenes are basically saturated hydrocarbons. Okay, saturated hydrocarbons, and these hydrocarbons, whenever you see the word hydrocarbons, you should know that these are the molecules that are made up of hydrogen and carbon purely. Okay, hydrogen and carbon. And when we look at the idea of alkanes, you should know. So let me just draw a molecule. Okay, for alkene. Now this CH4 is an alkane molecule. If I were to draw the structure for this, okay, so here you have C1, 2, 3, and 4. Now if you see, you also will get the idea of the bonding that we discussed in the previous part, which was that carbon makes 4 bonds. So one bond is here, one bond is here, one bond is here, and one bond is here. So these are 4 bonds for carbon. Okay, 4 bonds for carbon, and each hydrogen atoms has made how many? A single bond. So 1, 2, 3, and 4. So 4 hydrogens have made 4 bonds. Okay, now this is a alkane molecule, and using this alkane molecule we are trying to understand the idea of the homologous series. Now if I were to write the definition, if I were to say the definition of the homologous series, it says that consists a homologous series consists of a family of compounds, with the same general formula, and you'll understand what the same general formula is in a minute. The same general formula and similar chemical properties, similar chemical properties, because they have the same functional group. Now there are a few very important terms that have been mentioned here, and let me just mark them. A family of compound with the same general formula, similar chemical properties, because they have the same functional group. Let's first understand what does the term functional group mean. Okay, now again I'll draw a molecule, a structure of an alkane molecule. So this is CH4, right? Now let's try to understand what the functional group is. Now functional group, by definition I'm writing it as FG. Now functional group is something that is going to be deciding how a molecule actually reacts. So it's going to decide So this functional group here is going to decide how this alkane molecule is going to react with other molecules. Okay, so let's say I here the functional group in alkenes. For the whole alkenes, the functional group is a carbon atom bonded to a hydrogen atom or any other carbon atom. For example, in this part, the functional group is this one. Okay, C, a carbon bonded to NH. Okay, if I were to draw another alkane molecule, that was C2H8. Okay, that is C2H8. So that's 1 2 3 4 5 6. Oh, that is C2H6. Sorry, C2H6. Now here you have a carbon bonded to a carbon. So a carbon bonded to a carbon. So the alkene series is going to have the functional group for the alkene series is going to be carbon bonded to a hydrogen or a carbon bonded to a carbon. Okay, both of them can be called as the functional group. Now these functional groups decide how the molecule is going to react. It's how the alkene is going to react. So this is the first part. This is how we're understanding the functional group. Now, once we have the functional group, you should know that as we go down the list. So for example, we have CH4, we have got C2H6, we have got C3H8, we have got C4H10. Now these are all alkane molecules, and you will know in the later lectures how do we make them, how do we know all these are alkane molecules. But the idea is within all of these alkane molecules, the functional group is going to remain the same. Okay, it's going to be, for the first part, it's going to be carbon bonded to an hydrogen, because you only have one carbon here. For every other part, you're just gonna say the functional group is either carbon bonded to a hydrogen or a carbon bonded to a carbon. That is the idea. That is how functional group works. Okay, that is first major idea. Now let's go back up again. Let's see what were other parts. Similar chemical properties and the general formula here. Now let's look at this part as well. The general formula, and we'll see the whole general formula in a while, but let me just give you a quick introduction to that. Now here you see you have a CH4. Okay, you have a CH4 molecule, you have one carbon and you have four hydrogens, and then you have got a C2H6, and then you got a C3H8, then you got a C4H10. So what you are noticing as the series of the alkanes go down, what is happening here? You have one carbon, four hydrogens. Here you have two carbons, six hydrogens. Here you have three carbons, eight hydrogens. And here you have four carbons and 10 hydrogens. So every time you go down a series, what is happening? Carbon is increasing by the ratio of 1 and hydrogens are increasing by the ratio of 2. So it was 4 here, 6 here, 8 here and 10 here. In the same way, carbon was 1 here, 2 here, 3 here, 4 here. So with every carbon, there is an addition of 2 hydrogens. Okay. Now this is not entirely the general formula. General formula for every series is going to be different, but this is the idea, and this is going to come later. I'm just marking them so that I can tell you at the end when I write the points for the homologous series. Okay. Now let me go down a bit and let me write a few pointers for the homologous series. Now you see, the way we had the homologous series for alkenes, we're going to have an homologous series for alkene as well, for alcohol as well, for carboxylic acid as well. Let me draw one for alkenes so that you also understand. Now alkenes, the molecules start from C2H4. This is alkene. Okay, now the functional group for alkene was a carbon either bonded to a hydrogen or a carbon either bonded to a carbon. But a functional group for an alkene molecule is going to be different. What is going to be that? So you have a carbon double bonded. Okay, and we'll get to the idea of this double bond and all as well. But the idea is the functional group here is going to be this one. Okay, in alkenes, the functional group is carbon bonded to a carbon. If I look at any other molecule, that is C3 and H6. So now this is a carbon, and don't just focus on the bonds yet. We'll get into that in a few in other videos as well. Don't focus on that at these moments. I'm just gonna be erasing these because I forgot something. Okay, this is 1, 2, 3, and 4. That was 1, 2, 3, 4. That's right. Okay, that's 1, 2, 3, and 4, and that is 1, 2, 3, and 4. Now here you see C3 at 6. 1, 2, 3, 4, 5, 6. Here again, the functional group is a carbon-carbon double bond. That is the idea. If I look at for alcohols, for example, or yeah, let's look at for alcohols. Now for alcohols, if I were to draw a molecule as let's say CH2OH. Okay. Now the functional group in alcohol is going to look something like this. So I've got a carbon that is bonded to two hydrogens. I'm gonna so it's going to be C3OH. Sorry. So CH3 and an OH. Okay. Here the functional group is this part. A carbon, or not a carbon by the way. You can just say the functional group is this OH molecule. Okay, this is the functional group. So for alcohols, alkenes, carboxylic acids, the functional group is going to be different for each individual homologous series. So for the homologous series of alkenes, the functional group is going to be carbon bonded to a hydrogen or carbon bonded to a carbon. For alkenes, it's going to be a carbon double bonded to a carbon. For alcohols, it's going to be OH. For carboxylic acid, it's going to be CO double H. Okay, that is the idea of the functional group. And now let me write a few characteristics so that this can fit in perfectly.